All right, thanks for joining me. Today we're going to be looking at lesson 313 in our ebook, looking at how figures are related and how we can use ratios of similarity. Our big learning target today is that we're going to be determining the ratios of the perimeters of similar figures by setting up and solving equations to solve proportional problems. Okay? We've learned about similar figures yesterday. We've learned that each side lengths have been multiplied by a common zoom factor. We've also learned that the angles don't change in those similar figures. Today we're going to be looking at how changing the size of a shape changes its perimeter. So first we're going to warm up. We're going to practice writing and solving some proportions to solve for the unknowns. I'll do the first two and then I'll have you enter your answers for the second two in a minute. So I'm going to compare corresponding sides. So 2 corresponds to 4, just like 6 corresponds to x. This gives me a proportion that I'm going to solve. I'm going to multiply both sides by the denominators. This is the fraction buster method. Don't need that dot there. Okay, and then these x's cancel here, the 4's cancel here, and I'm left with 2x is 24, which means x is 12. Okay, now you might have been able to look at this and just realize x was 12, but I want you to practice setting up these proportions because eventually we won't be able to just tell, and we might have some expressions in there, not just numbers, so having that skill to fall back on is important. Okay, again, the directions told me these figures are similar, so I know that I can do this. The sides have to be proportional. So what I would like you to do for part B is pause the video, and then when you have an answer, go ahead and type it in, and then you'll be able to resume the video and see if your answer is correct. All right, so let's check answers. 3 compares to 4. They are corresponding sides in the similar figures, and 6 corresponds with x. Now, since the 3 came from the figure on the right and that's on the top, the 6 also coming from the figure on the right has to be on the top. The numbers that come from the figure on the left are on the bottom, making sure we get those lined up correctly. I'm going to multiply both sides by 4x. And then my x's are going to cancel here. And I'm left with 3x equals 6 times 4 is 24. Giving me x equal to 8. Okay. Take a minute, pause the video, and try part C here. Once you've entered your answer, come back and press play and see if you got it correct. All right, this one was a little trickier in the fact that you don't know this side length here. You have to do a little bit of work to find it. This is a rectangle, and they tell me the perimeter is 60. Because it's a rectangle, the bottom is also 21, and then those two together make 42. So if I do 60 minus 42, I have 18 units left to be split evenly. Each side has to be 9. Then I'm going to compare 3 is to 9 as x is to 21. And I'm going to multiply both sides by 21 times 9 and 21 times 9. My 21s are going to cancel, my 9s are going to cancel, leaving me with 63 equals 9x. So I'm going to get x equals 7. Okay, now we're going to take a look at some perimeter problems. All right, Casey's back at it. If you did yesterday's assignment, Casey was graphing some C's. Today she's enlarging a U. It says copied onto graph paper and now enlarge the U with a zoom factor of 1.5. So I've already drawn this. This is my original. I have all my lengths marked. A zoom factor of 1.5 means I'm just going to take these lengths and I'm going to multiply them by 1.5. So 8 times 1.5 is 12. So I'm just going to start and I'm going to go down 12. I think that's 12. I'm going to take this 2 and I'm going to multiply it by 1.5, which is 3. I'm going to take this 6 and multiply by 1.5, which gives me 9. Okay, and the 2 in the middle is, again, times 1.5 gives me 3. And then I can use some of the symmetry of this U to help me finish this. So this is the scale factor, or the zoom factor of 1.5. Okay, this was 12, 9. I'm just going to put these numbers in here. So that's what the version of 1.5 looks like. Let's go back and see what other questions it wanted me to answer. What is the height of the new U? Okay. So looking at it, my height of this U is going to be 12 units. Find the ratio of the perimeters. That is, find the perimeter of the new compared to the perimeter of the original. Okay, so I'm going to go and I'm going to work my way around here. I already did this once, which is I have this highlighting here. I like to use these tools to help me make sure I get all the pieces. So I'm going to do 8 and 2 makes 10. Another 8 and 2 makes 10 more, so I'm at 20. I have 28 plus 6 is 34 plus another 6. The perimeter of my original is 40. Okay, now the perimeter of my new, 12 and 3 makes 15. This is 15 more, so I'm at 30. I have 3 9s, which I know 9 times 3 is 27. And then I have this 3 more, so 27 plus 3 more is another 30. So the perimeter of my new one is 60 units. Now it asked me to compare the perimeter of the new to the perimeter of the original. And if I simplify that, that simplifies to 3/2 or 1.5. If you notice, that was the zoom factor that we used. So when we used a zoom factor of 1.5, the ratio of my perimeters was the same. I wonder if that's always true, or I wonder if it's just something special about these shapes. Let's look at the last one. Casey enlarged U proportionally so that the height was 10. What was her zoom factor and what was the new base? Well, if this is her original, her height of her original was 8. She made a bigger one where the height was 10. Her original base was 6. I want to know what her new base is. And I want to know what her zoom factor is. Well, to find her zoom factor, I'm just going to simplify 10 over 8. I'm going to compare the new one to the original. 10 over 8 simplifies to 5/4. So I know that that was her zoom factor. Now, in order to solve for the base, I'm just going to write an equation. I'm just going to go 10 over 8 equals b over 6. And then I'm going to multiply both sides by 6 times 8. My 6's are going to cancel, 8's are going to cancel, and I'm going to get 60 equals 8b. And when I solve that, I think I get a decimal value. Yeah, I divide by 8 and I get 7.5, which is fine. I can have 7.5 units for the base. Okay, again, I'm using proportions. I'm comparing like things. I did 8 or 10 over 8, so then I do b over 6 to solve. I'm still interested in this perimeter, though. I wonder if that's always the same. Okay, I want to talk about angles a little bit before we follow up on that perimeter. After enlarging his U, like we did, Al had an idea. He drew a 60-degree angle, then he extended the sides of the angle so they're twice as long, and he said, there, the angle must have a measure of 120 degrees. Do you agree? Discuss this and write a response to Al. So normally we'd have this discussion in class, but we're just going to trace this. And now if I take this and move it over, and I make those lines longer, I didn't change the angle at all. Similar figures and dilations have angles that stay the same. Angle 2 is still 60 degrees. All right, we have one more to look at. Al was working again, and he noticed that the ratio of the perimeters of two similar figures is equal to the ratio of the side lengths. Oh, so that question I had, I'm wondering if it's always the same. Al noticed that too. What about the area? Does it grow the same way, he wondered? So we're going to look at the rectangle above, and we're going to do some investigating. The area of the rectangle above is 21 square inches. The perimeter of the rectangle above is, this would be 3 and 7, would be 20 inches. Test Al's question by enlarging the rectangle by a zoom factor of 2. Okay, so I'm just going to sketch it here. So this is 6, 14, 6, and 14. Then find the new area and perimeter. Well, the area is going to be 6 times 14. And if I quick multiply that out, that's going to be 84 square inches. The perimeter is going to be 6 plus 14 is 20. I have 2 of those. It's going to be 40 inches. So what happened to the perimeters and the areas? My scale factor, my zoom factor was 2. Oh, and look at that. My perimeter also grew by an area, or by a ratio of 2. Did my area grow by a ratio of 2? No. Does the perimeter double? Yes. The perimeter has the same ratio always. It has the same ratio as the zoom factor, always. Does the area double? In this case, if the area would have doubled, it would have had to be 42. No, it doesn't double. In this case, it quadrupled. We will study how area grows more in a later unit. But right now, I want you to know, a big takeaway from the day is that the perimeter has the same ratio as the zoom factor. All right, I hope this helped and you were able to solve some proportions. If we go back to our learning target, it said that we would learn how changing the size of an object affects the perimeter, and we talked about the perimeter has the same ratio as the zoom factor. Make sure you make a note of that. That'll save you some work as you're solving some equations and be helpful for you in your homework. Thanks for watching.